All right, Algebra 2 lecture 224-25 OAS A2A14. The student will use synthetic division to divide polynomials. We're just going to take one polynomial, divide it by another one, and we'll be done. I'm going to show you how to do it using synthetic division. Our instructions say use synthetic division to divide the following. I've got this polynomial divided by this little polynomial. Okay. When I'm using synthetic division, the first thing I want to always do is make sure that the one I'm dividing by, the leading coefficient, is a 1, which it is in this case. And I want to check my powers of the one I'm dividing into and make sure that all of the powers are showing, that I'm not missing any powers. So 3, these are exponents. 3, 2, there's an invisible 1 right here, and you can think of this as v to the 0, because that's 30 times v to the 0. Anything to the 0 power is 1, as long as it's not 0. 0 to the 0 power is undefined. So this would be 30v to the 0, so I've got all my exponents showing. 3, 2, 1, v to the 0 generally doesn't show because it's just a 1, and 30 times 1 is 30. So we won't show that one. But we'll show all the rest of them. 3, 2, 1. We want to show them all. They want to be in descending order. This, by the way, could be written like this, and it means the exact same thing. So if you were asked to divide this or this, you would do the exact same thing. And I'm going to show you how to do it. So here we go. I've made sure that those were correct or in place, or what I'm looking for. Now I'm going to divide like this. I take the coefficients of the one I'm dividing into. Take the coefficients of the one I'm dividing into, and I just write them in a row. Not adding them or subtracting them, just writing them in a row. 1, -7, 2, and 30. Then I make a weird L-looking thing, and I take the opposite of this number. This is a -3, so I'm going to take a +3, and I put it right here. Now I'm ready to perform my synthetic division. What I'm going to do is follow a pattern, and it'll be the same pattern over and over again, and when I get done, I'll be looking at the coefficients of my answer, of my quotient, okay? So here's the pattern that I'm going to follow. I'm going to bring this straight down, always bring the first one down, multiply these two together and put it here, then add these together, then multiply these two together and put it here, then add these together, and multiply these two together and put it here. Okay, and this last one will be our remainder if there is one. Okay, so what I've done is I brought this one down, multiplied, put that here. Then I added, multiplied these two together and put it here, added, multiplied these two together and put it here, and added. I'm done with my synthetic division. What I'm looking at right here are the coefficients of my answer, and my variable is going to be a v. These are my coefficients, and my highest power of v is always going to be, in this type of synthetic division, will be 1 less than the highest power in the one I'm dividing into. Okay? So I'm going to have 1, that's my leading coefficient, v to the second, that's 1 less than that, v to the second, minus 4, v to the first, minus 10, v to the second, v to the 0. And remember, v to the 0 is a 1. We don't hardly ever show it like that. And plus a 0 remainder. Now, this is what we have. It's hardly ever written that way, though. It'll be written like this. V squared. They don't bother showing the 1 coefficient. Minus 4v. They don't bother showing the 1 exponent because it's implied. Minus 10, they don't bother showing v to the 0 because that's implied. And they don't bother showing plus 0 because if you don't see a remainder, then it's implied that the remainder is 0. So this is our answer. Pardon me, let me get a drink of water. If I haven't made any mistakes. Let's see if I did. Okay, and that's not my right answer. That's not the correct answer. There's one. There we are. V squared minus 4V minus 10. Yay. Let's take a look at another one. We'll do the exact same thing. It's not hard. Here I've already put those in place just to watch out for. I'm looking to make sure that I have all my powers showing 3, 2, 1. There's a V to the 0 here. I don't need that, but it is there. 3, 2, 1, V to the 0. And this is the number that I'm going to put outside my weird L looking thing. I'm going to take the opposite of it. So I've got everything in place, ready to do my synthetic division. I'm going to take these coefficients, 40, negative 53, that's a whole big minus sign. I just write those down, and then I make this weird V looking thing, or V, it's an L looking thing. And then I take the opposite of this number, put it here, and do the exact same pattern that I did before. I'm going to squeeze this just a little bit. Okay. So here we go. The pattern is we bring this first one down. Oh, and I did make sure that this was a 1. I don't know if I mentioned that, but that's got to be a 1 before I can use this. And I bring this down, I multiply these together, and that'll be 45, and it will be negative, because negative 9 times 5. And then I add these together, negative 5. They're different signs, so I subtract and keep the sign of the one with the greater absolute value. Then I multiply these two together. This will be positive 45. And I add these together. Make sure my brain will not mess up. Yep, that's an 8. And it'll be negative. Then I multiply these two together. And then I add those together. Add these down. It'll be 72 minus 65. I'm going to do it with my calculator because my arithmetic has been horrible today. And I keep the one with the greater absolute value. This has a greater absolute value, so it'll be positive. These are the coefficients of my answer. My answer, my variable will be a V. The highest power of my answer will be 1 less than that. It'll be 2. So this will be 5V squared minus 5V minus 8. And this time I have a remainder. Here's how you handle your remainder. It's simple. You just put plus, and you put 7 over. You're going to write it as a fraction, whatever it is you're dividing by. Well, what are we dividing by? V plus 9. Last number, if this last number, when you subtract this, if you don't get a 0, that's the numerator of your remainder. The denominator of your remainder is whatever it is you're dividing by. Okay? And I need to check and see if I got that right. I probably did. 5V squared minus 5V minus 8 plus 7 over V plus 9. Don't forget to put that plus sign there. So, yay, I got it right. What do you know? Yay for my calculator. So there's 1, there's 2, there's 1 more here. And the first thing I'm going to do is make sure that this is a 1, which it is. And make sure that all my powers of, in this case it's X, are showing. So 3, 2, I'm missing 2. So what I'm going to do now, before I start doing division, before I lay out all my, before I do this, I've got to show all of my powers. So I'm going to think of this as x to the third power. I don't have any 0, x to the 0, I can't speak. I don't have any x to the second power, so I'm going to say I have 0 x to the second powers. Then I have minus 36 x to the first power. Then I have plus 1 x to the 0 power. And that's divided by x minus 6. Now, I've got everything I need to be able to use synthetic division. This has to be a 1, and I have to show all of my powers. This is 3, 2, there's an implied 1 right here, and x to the 0. So I'm not missing any powers like I was here. I was missing x to the second, so I filled it in with a 0 coefficient. Now I can see it, and I can use my coefficients in my synthetic division. So here we go. I'm going to write the coefficients of these in a row. This is an implied 1 right here. So that's 1, 0, negative 36, 1. Once I get all of these coefficients written, I do my little weird L looking thing there and put the opposite of this number right here. Then we perform the synthetic division just like we did above and try not to make any arithmetic mistakes. That's why I have my handy dandy pocket calculator here somewhere. This morning my arithmetic has just been atrocious. I don't know why. Bring this down. Multiply these together and put it here. Add these. Multiply these two together, put it here. Add these. I got 0 here, but I keep going. Add the and multiply these two together, put it here, and add these. There's my remainder. This last one is the remainder. And now what I'm looking at, my highest power, my variable is going to be x. My highest power of my answer is going to be 1 less than this. So this will be 1x squared plus 6x to the 1, which I'm not going to bother showing the 1. You can. Plus 0. And I do have a remainder. And I'm going to use my remainder, write my remainder as 1 over whatever it is I was dividing by. Okay? X minus 6. Now, normally, you won't, when you're looking at a multiple choice scenario, you won't see this, and you won't see this. Those are implied. And you won't see this. They'll write it like this. X squared plus 6x plus 1 over x minus 6. It has all the same information. We don't usually show a leading coefficient of 1. We don't usually show the first power as a 1. We want to make sure it's there if we're using synthetic division, but we don't show it. And if you add 0, it's not really adding any information. And there's our remainder. So hopefully that's correct. And I'll check it here in just a second. And that's how you handle if you're missing one of your exponents. Hopefully I haven't messed it up. X squared plus 6x plus 1 over x minus 6. X squared plus 6x plus 1 over x minus 6. So yay! And there's synthetic division. Hopefully that makes sense. You can do this.